This is an introduction to sigma notation using integration. So in this lesson, we'll be going over how to express a definite integral as a limit including a sigma notation, and vice versa, how to find the definite integral from a limit using sigma notation. So in this case, we are converting the limit, which includes sigma, into a definite integral. Now, the first step is identifying your x value, your value of x, because your definite integral will be in terms of x. So the first thing that you should look for is the x value. A neat way to find out what your x value is see if any terms are repeated, or if any group of terms are repeated. And in this limit, we can see that 3 plus 2i over n is repeated twice. Now, when looking for your x value, we're looking at the term that contains I over n, because that is essentially your x value. So if there is no repetition, or if 3 plus 2i over n squared plus 7 was there instead of negative 3 plus 2i over n, we know that the x value is 3 plus 2i over n because it contains I over n as one of the terms. Now, the reason why it's 3 plus 2i over n and not 3 plus 2i over n the whole square, or just 2i over 10, is because this is in closed brackets. So because it's in brackets, we know that this whole value is x. If, for example, 3 was not here in both, then the x value would still be 2i over n. And in this case, there are two terms inside brackets. So we're looking at the term that contains I over n, as it is with this and this. But if there are brackets and there's another term included, that means that whole set of terms is equal to x. So, like I said, we're looking for the value of x first. So we can see that x is 3 plus 2i over n, right? So what we can do now is, when converting from a limit to a definite integral, we can first write the integral symbol, and before writing the bounds a and b, we can write our function, our expression first, which will be replacing this with x. It will be x squared minus x, and there is also plus 7 here, and so that will be our expression. That's the first part, and always write dx because it's in terms of x. That is our first part. We got the expression. Again, we're just looking for what is our x value, looking for what terms have I over n, and looking for their brackets around it. And so that's why x is equal to this, and we just replace that value with x. Now, to find the bounds, we need to adhere to this formula, b minus a over n, right? So you should probably be knowing the formula for a definite integral is just something like this, okay, where a is the bottom bound and b is the upper bound. So using that connection, we can say b minus a over n is our height. That's equal to your height. Keeping in mind this is a limit, our height is always going to be outside the bigger square, usually square brackets, or will be the value which is which has a denominator of n, only n, because as you can see here, b minus a over n, there is no constant or variable attached to the n. So the height, this is equal to the height, and the height in a limit is always the term outside of the big brackets, or whatever term has n as the denominator and no I, only a constant. A constant over n will be your height. So now identifying your height, we can say b minus a over n equals your height, which is 2 over n. Now, we're finding our bounds, right, of the integral, and we don't know b or a. How will we solve for two unknown variables? The key is the a value is actually given to us within the limit. The a value is whatever term that is added or subtracted to the term which contains I over n. So what I mean is, within our x value, within the value for x, if any constant is added or subtracted to the term with I over n, that is our a value. So in this case, it was x is equal to 3 plus 2i over n. So 3 is added to 2i over n. So, like I said, a is equal to the constant that is added or subtracted to the term which has I over n. So in this case, it's 3. So we know that a equals 3. That's already one bound, right? So that's one bound, 3. Now what's b? Using this formula, we can find b. Now n cancels out, so we get b minus 3 equals 2. And b equals 5, right? So b is 5, a is 3, the bounds are 3 to 5, the expression is this. That's done. That's our definite integral. Let's work on another similar question. Find the definite integral of this limit. Now, like I said, our first step is to identify the x value. The x value is always, firstly, if it's repeated, that's probably the x value. So in this case, you can see that 1 plus 3i over n is our x value. And to solidify that, we also know that the x value should contain I over n, right? And the reason it's 1 plus 3i over n is our x value and not just 3i over n is the reason because there are brackets around it. If there are brackets only around 3i over n square and 3i over n here, and 1 minus 1, it was just 1 plus 3 something, and the 1 was outside of the bracket, then the x value would just be 3i over n. But because the 1 is included within the bracket, our x value is 1 plus 3i over n. Okay, so now all we do is replace 1 plus 3 over n with x in our definite integral. So forget about the bounds for right now. X squared minus x plus 7. Very similar to our last question. And dx. Our second step was identifying that b minus a over n is equal to our height. In this case, our height is similar. It's 3 over n because it is the term with a constant over n. And that's 3 over n. And in this case, the a value is the constant which is added or subtracted to the term the term that has I over n. So in this case, it's 3i over n plus 1. So we know that a is equal to 1 because that is part of the x value, right? That's what's being added or subtracted to our term which contains I over n. So using this, we can write our lower bound is equal to 1, and our upper bound, we can just use this formula. b minus 1 is equal to 3. The ends cancel out. So b is equal to 4. And we can write this. And so that is our answer for this question. Another one, converting to a definite integral from a limit. So from this limit, our first idea is acquiring the x value. X value, again, the group of terms that is repeated. Here we can identify that's 5 plus 2i over n, which works because it contains the term I over n, right? So you can write 5 plus 2i over n, right? And incredibly similar to the previous questions, we can first write the integral notation, and then replace the 5 plus 2i over n with x. So we have sine of x minus natural log of x dx, right? This is our height. Second step, b minus a over n equals to our height. Our height is 2 over n because it's a constant over n. And a in this case, a should be 5, right? Because it's added to the term that contains I over n. 5 plus 2i over n. So a is equal to 5, and so b minus 5 equals to 2. b equals to 7. So a is equal to 5, b is equal to 7. And that is our indefinite integral. Now let's switch it up a bit. Let's go from an indefinite integral to a limit containing sigma notation. Now, one thing to note is whenever you face this type of question and it asks you to convert it to a limit, we can always use this basic equation. The limit as n approaches to infinity, and with sigma n on top and I equals 1 on the bottom. And that will be true for any definite integral when you're converting it to a limit. So limit as n goes to infinity, n on top, and I equals to 1. Lowercase I equals to 1. Now the variables can change, it does not matter, but this is the basic formula. This is what you write each time they ask you to turn a definite integral to a limit. In the previous cases, all of these, the initial limit was equivalent. Limit as n approaches to infinity, sigma n on top, I equals 1. Here, limit as n goes to infinity, sigma n I equals 1. So in this as well, we'll use the same basic outline, and here x is given to us, x plus 5, right? So what we're doing is working backwards. We're working backwards. So when we work backwards, the first thing you want to do is find the height. Find the height. And what we can do to find the height is use this formula, right? Because that's equal to height. And we know the height is always at the end, right? At the end of the limit, just like how these questions were. So this is equal to height, and we know b is equal to 5, and a is equal to 1. We can do 5 minus 1, 4 over n is our height. So you already got one part of our limit. Now all we need to do is find our x value and then add 5. So what we can do now is, like I said, our x value contains our a value, right? Our a value is either, depending on if our a value is negative or positive, it's added or subtracted to term which contains I over n, right? So our a value is given to us, it's 1. So that's the first part of our x value. And the term that contains I over n, let me go back. In this case, it was 2I over n. How do we find this constant? Like, the a value is 5 in this case, right? But how do we find the constant that is attached to I over n? Well, that's easy. The constant that is attached to I over n is just b minus a, which is 5. And that's going to be true for all indefinite integrals. Okay? So this is our x value. And so now we can just replace this with x. And then add 5. Now, one important thing to note is, like I said, if you want to include 1 into your x value, in this case, right, x is equal to 1 plus 5i over n, we need to put brackets around 1 plus 5i over n. If you don't put brackets, then our x value is simply 5i over n. And that is not what we want, because our x value is a plus the term that contains I over n. So we need to put brackets around 1 plus 5i over n. And so this is our answer. Now another converting it to a limit from a definite integral. We'll work backwards. First we'll write our basic outline. Limit as n approaches infinity, segmentation I equals 1, n. And now all we have to do is find the height first, so we can add that at the end. b minus a over n. I'll write it again. And so using this formula, we get b 6 minus a, which is 0, over n. 6 over n is our height. So we can add this to the end. That is our height. Now all we need to do is find the x value. Now x. Like I said, the x value, the first part of the x value is adding or subtracting the a value. In this case, the a value is 0, so we don't need to add or subtract anything. We just need to find I over n. Now what is the constant that is multiplied by I over n? Like I said, it's just b minus a, or 6 in this case. So for this, we can directly write 6i over n squared, and we don't need to put brackets around it because there is no a value. There is no constant like 1 or 6 plus this, so we don't need to put a bracket. It's just the I over n term. So this is our sigma limit, our sigma notation. And yeah, last question. Convert this definite integral to a limit. Again, write our basic outline. Limit as n goes to infinity, sigma n. Find the height. First part, find the height. b minus a over n. 6 minus 2 over n. 4 over n is our height. Next step, finding the x value. Okay? X value. First we add or subtract a. Our a value is 2, so we add a to our term with I over n. What do we multiply by I over n? What is our constant? It's 4, because it's b minus a times I over n. b minus a is 4. So now we can replace x with 2 plus 4i over n. Always remember to add all these natural log 3 times, add that to the end limit, because otherwise it will be wrong. So natural log of 2 plus 4i over n minus 3 times, make some room, 3 times 2 plus 4i over n. Okay? And don't forget about the height, which was, as we calculated, 4 over n. So this is our sigma notation. This is our limit from the definite integral.